In this video, I'll present a paper titled To Reuse or Not to Reuse, a Framework and System for Evaluating Summarized Knowledge. My name is Xieyang, and this is a joint work with Professor Aniket Kittur and Brad Myers. As the amount of information online continues to grow, a correspondingly important opportunity is for people to reuse knowledge summarized by others. In this work, we explore this topic of reusing knowledge in the domain of programming. For example, to start a high-dimensional data analysis task, a developer searches and browses the web to find out the different APIs to represent matrices in Python, and runs into all kinds of detailed evidence about these APIs. To help him synthesize and inform a decision, he uses our previous research tool called Aniket, which enables developers to collect and organize information into a comparison table as they are searching and browsing the web. Naturally, later developers who also need to figure out what Python matrix API to use would benefit from just reusing this Aniket table, which is filled with the various options, criteria, and the evidence about the trade-offs that the first developer has already explored. Generally, in situations like this, reusing knowledge summarized by a previous person is clearly beneficial. However, a major challenge is that the consumers of the knowledge often do not know if it is appropriate to reuse or not, which requires examining additional facets. Prior work suggested that people instinctively care about the correctness of the knowledge, for example, by asking if the information sources were credible. In addition, there could be other facets that are involved, such as whether the goal and context of the author matches with the consumer, or did the author overlook some possible alternative options. None of which are currently straightforward by just, say, reading a Aniket comparison table. And unfortunately, prior work also showed that when people are not sure about these facets, they would rather carry out their own research than reusing someone else's results. So in summary, it is hard for consumers to systematically identify all the potential facets to verify before reusing summarized knowledge, and it lacks proper tool support to help them interpret these facets. Therefore, the true goals of our research are to provide a framework that systematically outlines all the potential facets to consider when evaluating the appropriateness to reuse knowledge, and to produce a prototype system to extract and surface the signals and properties that would help consumers interpret these facets. First, to generate the framework, we took a two-pronged approach where we interviewed 15 developers about their experience in reusing someone else's decisions, as well as assembling and coding relevant prior research on topics such as knowledge reuse, online information credibility, and sense-making handoffs. We identified three major facets from this research: the original author's sense-making context, the trustworthiness, and the thoroughness of the sense-making results, each augmented with developers' specific information needs uncovered from the interviews. First of all, context. Developers would often like to know how relevant the original problem context is to their own unique situation. For example, if a developer is working in Java, then solutions that only work in JavaScript may not be worth investigating at all. And it's worth noting that developers tend to check the relevance of context before even considering trustworthiness, at least in the programming setting. Context is captured by three specific information needs, including the goal of the original author, such as to pick a speech recognition API rather than a speech synthesis API, explanations or contextualization of information, such as what does this algorithm is very efficient mean? Is it memory efficient or time efficient? And the situation in which the knowledge will be reused, such as does a particular solution requires me to install some extra libraries or a completely new version of Python, which I currently don't have. Second of all, trustworthiness, which intuitively plays a huge role in the reuse evaluation. The credibility of sources is one aspect of trustworthiness. For example, developers are more inclined towards trusting information from official sources or those with good reputation, such as API documentation or Stack Overflow. In addition, it is also very important that the information used by the author was up to date, which is especially true in today's software development world, where languages and libraries are constantly being updated, and older versions could quickly be rendered obsolete. Other aspects of trustworthiness includes information popularity, consistency, and the credibility of the or knowledge author, which you could read in detail from the paper. Last but not least, thoroughness, which examines the process and the amount of effort used by the author when creating a knowledge artifact, which would give the consumers a sense of how much work has been done and how mature the knowledge representation is. On the flip side, developers would also like to understand alternative options or solutions that were not necessarily considered previously, but can still be useful to them right now. In addition, usable artifacts like example code that the author ended up using are also valuable information. Notice that the previous information needs cannot be easily fulfilled by just looking at the final decision results or the design rationale captured by Unikite comparison tables. Therefore, we built a prototype system called Strata on top of Unikite, which does two jobs: to extract signals and properties that would address consumers' information needs in the framework as the author was creating the comparison tables, and to present them in a sidebar that would help consumers interpret the context, trustworthiness, and thoroughness of the tables. In addition, Strata also augments the table content with additional information about whatever the user selects in the sidebar. In the context panel, users will be able to view the queries used by the previous author captured by Strata to understand the goal of the original decision. Strata also automatically takes a snapshot of the surroundings of an information snippet when the author captures it, which could later help consumers understand exactly what the snippet means in context without having to track down its source webpage or location. In addition, Strata uses heuristics to detect the language, framework, and platform versions used or mentioned in the collected information snippets to help consumers quickly compare those with their own situations. In the trustworthiness panel, Strata visualizes the distribution of the snippets across different sources to give consumers a high-level overview of the provenance of the information in the table. Users are also able to view additional signals about evidence popularity and up-to-dateness. So for example, it shows that this snippet, which was taken from Stack Overflow, has 5 upvotes, is the officially accepted one, and was updated 3 months ago. In the thoroughness panel, users can see a timeline of the author's research process, which is organized chronologically and grouped by the search queries. Strata also leverages the Google Autocomplete API to automatically find commonly searched for alternatives to the existing options in the table, offering insights into potential new options for consumers to explore. Finally, Strata also extracts any code snippets included in the table for knowledge consumers to directly examine and try out without having to dive deep into the table content. So that was a high-level walkthrough of the system. There are more features and details described in the paper if you're interested. For evaluation, we conducted a lab study to understand how useful the framework is in terms of helping developers evaluate the appropriateness of reusing decisions and how effective Strata is in doing that compared to just reading original Unikite tables. Participants were asked to read comparison tables about different programming decisions and explain with specific reasons of why they would or would not reuse those decisions. In the end, we found that participants who used Strata finished significantly faster and at the same time came up with significantly more valid as well as high-quality reasons of whether to reuse decisions or not. Participants also provided positive feedback to Strata, such as it served as a guidance for things that they should pay attention to during reuse, which underlies the value of the framework, and reminded some participants of the appropriateness properties that they would otherwise overlook. In addition, they were also excited about authoring tables with a tool like Strata running in the background to automatically collect relevant honest signals, which would be particularly useful when they ended up having to justify their decisions, such as during code reviews or project handovers. So to conclude, appropriate reuse of previously created knowledge requires judging its context, trustworthiness, and thoroughness in relation to an individual's own goals and context. Providing user-centered scaffolding that obtains and visualizes signals for reuse can be a fruitful approach to facilitate knowledge consumers' reuse decisions. Our work points to the importance of having tool support that helps people more efficiently organize and manage information as they find it in a way that could also be beneficial to others. and therefore bootstrapping the virtuous cycle of people being able to build on each other's sense-making results and facilitating efficient collaboration and knowledge reuse in the future.